Welcome back to my wetland plant identification class. I'm your host Abe Lloyd, and we have a treat today. We are at Dailey Prairie, which is a site that you need special permission to get to, but we got all the paperwork done. So I'm excited to explore this. I want to give you a little bit of a site overview. This is a type of wetland called a fen, and fens are one of two types of sedge or of peat accumulating wetlands. We have bogs that usually accumulate sphagnum peat, and we have fens that typically accumulate sedgy peat. And so fens are really dominated by graminoid or grass-like plants, and if we look around here, we could see that all these things are, most of what we see is grassy looking, and most of them are actually sedges, so this unit will have an emphasis on sedge identification. Now, fens usually in the landscape are found in areas that get a little bit of groundwater flow, so they're not isolated from the rest of the hydrology like peat bogs, but they typically are in very poorly drained sites. So we could see the Twin Sisters in the background. We're in what's called a saddle. So the Twin Sisters are on this side, and then on the other side over here, we can see a ridge line. And then over this way, there's a creek that drains down that way. And then on the other side of me, there's another creek that drains down this way. So water is shedding onto this fen from two sides, and it's also draining out of the fen from two sides. But it's essentially flat because it's at the top. It's in this saddle position where it can get lots of water, but the water drains really poorly because it's at the top. And that's one of the things that is unique about this site, and I think makes fens a little less common on the landscape, is you need to have a poorly drained site like that. Our fens typically are at a little bit higher elevation, and this is a result of abiotic factors. I've talked about this in several lectures in the past. Water is stressful to a number of plants. Up here, we're at 3,200 feet. We're starting to get into a colder climate, and so cold temperatures can be stressful to plants. And there's actually, I would guess, a little bit about this geology that's also stressful to plants. And so woody plants don't handle submersed roots very well. They don't handle extreme cold temperatures very well because they persist all year round, and these wetland plants, they go dormant in the winter, and they have all these adaptations for dealing with wet conditions, and so those enable them, all those abiotic factors combine to make fens a little bit more probable when you're up a little bit higher. Just more abiotic stresses, and trees are basically king in most environments, so when it's too wet for trees, then you could have other things, and in this case we have a fen. We're fortunate in that we have two guests today, and the first I want to introduce is Bud Hardwick, and he is the site steward for the DNR for this Dailey Prairie site, and he's going to give us a little bit of background about the Dailey Prairie.
Well, great. Welcome to Dailey Prairie. This is one of 50 designated natural area preserves by the Washington State Department of Natural Resources, the DNR. My name is Bud Hardwick, and I've been a site steward of this prairie and other local sites since the program began nearly 20 years ago. Being a DNR steward has been one of the most fulfilling activities of my life. It has taken me down fascinating pathways in the natural and physical sciences, as well as cultural and archaeological investigations. I highly recommend this program for anyone who's interested in helping to preserve some of the very special areas in our state. These unique natural area preserves were designated because of outstanding natural characteristics that exist there, and in some cases, unique characteristics. Because of the desire to preserve them for future scientific and educational reasons, you're only allowed to access these natural area preserves with DNR permit and, in some cases, supervision. There are other conservation areas managed by the DNR that allows recreation, but natural area preserves like Dailey Prairie do not. The uniqueness of Dailey Prairie is formed by several layers of considerations. To the east, behind me, is the Twin Sisters Range, a reddish-hued upthrust of deep mantle rock forming the second largest exposed structure of dunite and olivine on the planet. The mineral that it is associated with is valuable commercially, and so there has been a long history of mining in this area, including one active mine which still remains today. The chemical characteristics of olivine, however, are toxic to varying degrees to many plants, thus forming another unique character of this particular site. Behind me, the slope of the west ridge of the North Twin Sister slopes down to Dailey Prairie. Following through to the west, it rises up on the slopes of Bowman Mountain. Typically, and in almost every circumstance, this would have formed a very narrow, nondescript pass. However, for whatever reason, there's over 100 acres of flat land, which is extremely unusual to find at this elevation of 3,200 feet. The rain and the snow melt from these areas filter down here and fill this flat area. However, the water drains very slowly. To the north, it drains down into the middle fork of the Nooksack River, and to the south, into the basin of the South Fork. The presence of water here for such a long period of the year is what is probably responsible for its openness, preventing reforestation on here. So I hope you enjoy your virtual tour of Dailey Prairie, and you'll visit other DNR special area sites on the DNR websites.
And the other guest I want to introduce is Barry Wendling, a friend and fellow botanist. He's at Western Washington University and is the plant manager at the Pacific Northwest Herbarium, housed inside the biology department at Western. So Barry is going to be helping us identify stuff. He is really good with sedges and, well, all plants really, but the main reason I brought him along is for his sedge expertise.
Well, thanks for being so generous, Gabe. I'll do what I can today. I'll try not to make too many lies.
Okay, so we're gonna just mosey around here, and there's about 28 to 30 species I'm hoping we'll find. The emphasis is gonna be on sedges, and actually maybe we can just get started with this one here. And I'll give you a little overview, didn't get one, on some sedge parts. So this is actually a pretty rare taxa in the state.
The biggest population is here.
Yeah, and Barry says the biggest population in Washington state is here. But some features, we've seen a couple sedges before, but some features are that sedges often have flowers that are divided into spikelets. So this is the male spikelet. We would say that this is a terminal spikelet because it's at the tip. Then we have these two female spikelets. We know they're female spikelets because they have the seeds. And they are they're dangling on this structure that is called a peduncle. So in a key, you might see that this is described as a pedunculate sedge, meaning that the spikelets have peduncles. Okay, some other features, if we take and pull off one of these peduncles or spikelets and we crush the seeds a little bit, we can see that there is this green structure and a black structure. Now, they're not always green and black like this, but this is great because it's a lot of contrast, easy to see the different parts. The seed is called the achene, and the seed is enclosed in this sac-like thing called a perigenium. So actually the green thing we see is the perigenium. And then all sedges have seeds or perigenia that are subtended by a single scale. And the scales on this sedge are black. So on the female spikelet we have the peduncle, we have several perigenium, and inside of each perigenium we have the achene, the seed, and underneath each perigenium we have a scale. Now, sometimes, like we saw in the bulrushes, sometimes the sedges will have a bract that's associated with a spikelet. I got lucky and picked one that happens to have a little teeny bracts structure. So bracts are leaf-like structures that usually are associated with a flower. What else? Another trait, as we saw with the bulrushes and the true rushes in the estuary, is that we need to pay attention to whether the species is rhizomatous or cespitose. So what do you all think for this Carex pluriflora that's growing everywhere here? Well, since it's spread out almost everywhere and we don't see distinct clumps, it's a pretty good guess that it is a rhizomatous species. But we would want to probably dig one up and look at the rhizome. If it's this long underground root that parallels the soil surface, that would tell us it's a rhizome, a rhizomatous species. So we're going to dive right into the sedge key, and I want to plug this book, Field Guide to Sedges of the Pacific Northwest, by the Carex Working Group. These are some dedicated sedge nerds out of Oregon that put this book together, and we have over 100 different species of Carex in the Pacific Northwest, so it's a very challenging group. And you know, in this class maybe I will cover close to 12 or so of the most common. But I gave you a little bit of overview of the terminology, and so now we're going to apply some of that terminology in this key. So it starts out comparing 1A to 1B. 1A reads spike 1 per culm, 1B spikes 2 or more per culm. So remember, I should say again that the culm is the supportive stem of graminoid, so we use that word with grasses, rushes, and sedges. So this is the culm, and these are the spikes. So is there 1 spike or more? There's 4 spikes on this one, so we can go with 1B. So that brings us down to 2A and 2B. 2A is all spikes entirely staminate, no perigenia present. 2B says some or all spikes with pistillate flowers, perigenia present. Okay, so a staminate spike is the male spike, and a pistillate spike is the female spike. So we have some female spikes and a male spike. So they're not all one or the other. So that we have to go with 2B then. Some or all spikes with pistillate flowers. 3A says perigenia hairy, and 3B says perigenia glabrous. Remember, glabrous means smooth without hairs. Okay, so I have to look really closely at the perigenia, and I could see that they are definitely smooth. Hairiness in a perigenia is an uncommon trait. There's just probably only half a dozen Carex species that have hairy perigenia. Hairy peri, some people say. Okay, so 3B, perigenia glabrous, that takes us to 4. 4A says stigmas 3, achenes 3-sided and cross-section, or 4B, stigmas 2, achenes 2-sided and cross-section. So just a little trick, usually when the achene is 3-sided, the perigenia is more inflated and rolls around a little easier in your hand. Whereas when the achene is 2-sided, usually the perigenia is flatter and doesn't roll around as easily. Actually, since this is our first sedge, I'm going to bust one of these perigenia open, and we're going to take a look at the achene on the inside. All right, so they roll around in the hand pretty well, but I took some time and pulled the perigenia off the achene, and we could see that the achene is indeed 3-sided, or trigonous, they might say. So all perigenia, or all achenes that are trigonous or 3-sided, also have 3 stigmas, which it mentioned in the key. Stigmas 3, achenes 3-sided and cross-section. So we can go and compare 5A to 5B. 5A reads perigenia open on one side, exposing the achene. plant short, densely cespitose, or 5B Perigenia closed, hiding the achene, plant and habitats various. So all the true Carex, the genus Carex, have closed achenes, closed perigenium, whereas there's a different type of sedge called Cobregia, and they have achenes that are slightly split open on the top. So we can see that this perigenia is totally sealed all the way around it. It just has the tiniest little hole at the very tip where the pistil will stick out. Okay, so we go with 5B, and we can compare 6A to 6B. 6A says styles persistent, continuous with the achene, perigenia inflated at least at the top, or 6B styles deciduous, not continuous with the achene, perigenia usually not inflated. So when we pull off the perigenia and we see the achene, does it still have the style, which is the structure that supports the stigmatic surface on the top? Does it still have that? And it doesn't, it's fallen off. So the styles are deciduous. Since there are so many sedges, this book has kind of this introductory key, and then it has a whole bunch of sub-keys. So the style's deciduous 6B, that spits us out to key F. And basically the key F defines a much narrower segment of sedges that all have 3 stigmas, perigenias that are not pubescent, and styles that are deciduous. So the first part of the key compares 1A to 1B. 1A says lateral spikes each with a single perigenium, or lateral spikes each with 2 or more perigenium. So these are the lateral spikes. And this one has 2, 4, 6, 8, 10, at least 15 or so perigenium. This one maybe only has 10, so definitely more than 2. So that takes us down to 2A or 2B. 2A says leaf blades normally entirely orangish brown, or 2B leaf blades normally green or glaucous. And the leaf blades are green. I go to 3. 3A says leaf blades hairy. 3B says leaf blades glabrous. So these are leaf blades. They feel smooth and they look smooth, so they are glabrous. Below 3B is 4A versus 4B. 4A says lower pistillate scales, leaf-like and green, similar to the leaf-like lowest inflorescence bract. 4B says lowest pistillate scales, not leaf-like, less than 10 millimeters long. This is a pistillate spike because it has the female structures, in this case the achenes, or the seeds. And the lowest scales are going to be the ones that are closest to the peduncle. We could see those black scales. So the question is, are they leaf-like or not leaf-like, essentially? And they are not leaf-like in this case. So we can go with 4B. So we'll compare 5A to 5B now. 5A says perigenia 9 to 15 millimeters long. I often skip the measurements if I can and see if there's a trait that's a little easier to see. So after that, it says inflorescence consisting of a single, dense, much branched head with many spikes. Or 5B says inflorescence consisting of separate spikes not crowded into a single head. So there we go, that's an easy trait, no measuring needed. We have several spikes that aren't crowded into a dense head. So we go with 5B. 6A versus 6B. 6A reads lowest inflorescence bract with a sheath greater than 4 millimeters long, or 6B lowest inflorescence bract lacking a sheath or with a sheath less than 4 millimeters long. Okay, so we're not measuring the length of the bract, we're measuring the length of the sheath on the bract. So this is a leaf here. This here is a bract because it's coming out from the same place that the spikelet is. So bracts usually are below flowers, like I mentioned. So the sheath is where the bract connects to the culm. And there is the bract sticking out at an angle. So the sheath would be right at the base. So we need to measure that sheath. And it looks to me like it measures at 2 millimeters, which I believe is less than 4 millimeters. So we can choose 6B, less than 4 millimeters long. We go to 7 then. 7A leaves 8 to 23 millimeters wide versus 7B leaves 1 to 8 millimeters wide. And these leaves are pretty narrow. I get 3.2 millimeters. So that means 7B leaves 1 to 8 millimeters wide. That brings us down to 10A or 10B. 10A says Perigenia with conspicuous beak, 0.8 to 2.7 millimeters long, or Perigenia beakless, or with a short beak up to 0.6 millimeters long. So the beak of a Perigenia is kind of like the beak of a bird, I guess. It's an area where there's a strong constriction in the Perigenia. These Perigenia do not really have a beak. Hopefully we'll see one later today that does have a beak, because that's a trait that comes up a lot in the keys. Okay, we're down to 11A versus 11B. 11A says terminal spike staminate, which would mean male flowers, androgynous, which would mean it has both male and female flowers in one spike, and in this case the male flowers will be on top of the female flowers, or with male and female flowers mixed. Or 11B says terminal spike gynecandrous, which means the female flowers in that spike would be on top and the male flowers would be lower down. Or pistillate, which just means all female flowers. So this particular terminal spike appears to all be staminate. So it's all be male flowers. So it's a staminate spike. So we can go with 11A. Now, unfortunately, we're at the end of that key, but we're not at the end of all the keys. We have more keying to do. Okay, so let's go to key F6. So we'll start with 1A versus 1B. Terminal spike 1.5 to 3.5 millimeters wide, staminate, Perigenia plus or minus round or trigonous in cross section. Or 1B, terminal spike 3.5 to 6 millimeters wide, staminate, androgynous, or with irregularly arranged male and female flowers. Perigenia strongly flattened, round, trigonous, or trigonous in cross section. So I don't need to measure because I know the Perigenia are round. We saw that earlier. Or trigonous, really, in cross section. So I can go down to 2. 2A says at least the upper lateral spikes erect to ascending. Sessile, which means without a stalk. So I'm already thinking no for this. 1B says all lateral spikes spreading to dangling on long, thin peduncles, young roots with dense yellow hairs. Okay, so all the lateral spikes have peduncles. They're dangling. See, I'm not the only one to use the word dangling in reference to sedge traits. Okay, so that was 2B was correct. So now we go to 6A versus 6B. 6A says pistillate scales much narrower than the Perigenia. 6B says pistillate scales wider than the Perigenia and wrapped around them, or not much narrower. Pistillate scales, those are the black things. And here's a the back side of one and the front side of one, and we could see that those scales are wrapped around the perigenia. We go with 6B, and under 6B are 7A and 7B. Pistillate scales, blackish, wrapping around the perigenia at base, or 7B, pistillate scales, medium brown or reddish, not wrapping around the perigenia at the base. And since they're wrapping around the perigenia at the base, we know it is Carex pluriflora. Now that was about the hardest species to key in this book because it ended up at almost the last branch in all the different keys we looked at. But I'm glad we keyed it because this is a very unusual sedge, and we would hate to be wrong on this sedge because people tend to care about the rare species more than the less rare species. So Carex pluriflora here at Dailey Prairie. Even though this site is dominated by sedges and other graminoids, there are some other cool plants here. And this is an herbaceous plant called elephant head's lousewort, or Pedicularis groenlandica. And the common name is really easy to remember because the flowers really look like elephant ears and trunk hanging out. It has leaves that are really finely divided, deeply lobed, and a lot of louseworts have pretty deeply lobed leaves like this.
So Abe thought he could use a little bit of a break, so he asked me to step in for a little while here and maybe talk a little bit about some of the other interesting sedges that occur here at Dailey Prairie. This is another one that's fairly common here. It's hard to miss. It's a rather large example of a Carex. I'm just going to go ahead and tell you the name of this. We're not going to go ahead and try and key it or anything like that. This one is relatively common in this part of the world. This is variously known as Carex sichensis or Carex aquatilis dives. You can differentiate it from another very closely related species or subspecies known as Aquatilis aquatilis by the nodding spikes. If you had Aquatilis aquatilis, these would probably be upright, something more like this. Some of the characteristics that help you differentiate this pretty quickly using keys are going to be, as noted earlier, the number of stigmatic surfaces, the nature of the spikes, whether they've got both male and females, and where the spikes are located. So you can see on this one, maybe you can see on this one, the top spikes are primarily made up of males, and the lower nodding spikes are primarily females. And you would know this if you look closely and you saw the perigenium, and you can see the stigmatic surfaces. I don't know if you can make these out or not on here. Some characteristics that help differentiate it from other taxa are that it's rhizomatous. You wouldn't know that because I picked it, but if you were to follow back down into the mud, you would see that there are quite a few of them growing around it, which suggests that it's not clumping, but rather running, so it's rhizomatous. The brown sheaths at the bottom are also another really good characteristic. And just the overall size kind of takes you a particular direction too, once you get familiar with looking at different sedges.
Here we have Carex luzulina, and sometimes the names give you a hint about what they might look like. So luzula is actually a genus called woodrush, and the woodrushes tend to have kind of leafier looking leaves, or more grassy looking leaves, I guess you would say. And this is a sedge that is cespitose, so here we can see a clump. It tends to have pretty wide leaf blades. So there is the perigenia, and here is a perigenia with the scale still attached. And here we get a look at some spikes that have female flowers at the bottom, and then the tip we see are some male flowers. So this would be our androgynous spike here. I recognize this one from a distance by the kind of loose look of the spikelets or spikes, they kind of arch out at an angle, and there's a lot of space between the perigenia. But I'm more of a Gestalt IDer than a lot of other people that like to look at very fine features. So Carex lusulina. What are some other features? We could see that the lower spikelet is pedunculate, but the upper spikelets are sessile, so they lack a peduncle. We can see that the bracts are pretty wide, kind of grass-like bracts. And then the basal cluster of leaves down at the bottom. Here we have Carex canescens, or silvery sedge, and this is a very small sedge, about the smallest sedge I know. And I often see this in bogs, especially right on the edges of bog mats. But it's pretty abundant here in the fen as well. Now, some traits. The spikelets are all sessile, and they're very short, so it looks like most of them have less than 20, probably most of them less than a dozen flowers per spike. And they mostly appear to just have female flowers. Of course, there's got to be some male flowers somewhere, but the male flowers are just inconspicuous. All right, we have a new sedge here, and this is actually in the same group as the Carex canescens that we just did. This is called Carex echinata. One really unique feature about the Carex echinata is that on the terminal spike, it actually has female flowers above male flowers. So that's gynocandrous on the terminal spike. And we could see that all the spikes are pretty much sessile. But if we compare canescens to echinata, look at how canescens, all the perigenia sort of point upwards, whereas echinata, they tend to point in multiple directions. And the common name for echinata is star sedge. Just like stars point in 5 different directions, echinata is pointing all over the place. And I find that a pretty useful trait. Now, the perigenia on echinata are pretty long pointed, so they have a long, slender beak, like the point of a star, perhaps. And that beak is oftentimes curved a little bit down. It's called reflexed. But Carex echinata is another one of those small sedges in a group that some people find pretty difficult. It likes growing in peat bogs and in fens. I tend to associate the plant with sphagnum moss, and even though we're in a fen, there actually is a little bit of sphagnum moss here, so look at that. The association proves correct. Here we have Viola palustris. This is a purple flowered violet that grows in wet areas. And there aren't a lot of purple flowered violets, and this one is growing in a wet area, so I'm going to call it Viola palustris. Heart-shaped leaves, like most violets. Here we have Carex utriculata, and this can be a very robust species. I think if any sedge is going to look a little bit like a corn plant, this is the one. So it can get to be maybe 3 feet tall. It has usually multiple male spikelets that are terminal towards the top of the plant, and multiple female spikelets that are always lower down. Now it's sessile, the spikelets, and let's see. Well, let's take a close look here at the female spikes. We actually can see the stigmas sticking out of the end of the perigenium. Each style has 3 stigmas. So the Achenes are not yet developed because it hasn't even flowered yet, but the fact that it has 3 stigmatic surfaces is going to tell us that the achenes are going to be trigonous, whereas if it had 2 stigmatic surfaces, then the achene would be flat. Here we have Caltha leptosepala. This is sometimes called white marsh marigold, and it has a leaf that looks a little bit like a violet leaf in that it is cordate. See these scalloped margins, it's a good trait. The flowers are white, white petals, and it has these yellow stamens, many yellow stamens, and several pistils in the middle. Here is one that has actually gone to seed, or going to seed, and so this came from one flower. We have 1, 2, 3, 4, 5 seeds, so that must mean that there was at least 5 pistils in the flower. This is a plant in the Ranunculaceae, or the buttercup family, but it doesn't have a yellow flower, it has a white flower. It likes growing in wetter areas, usually at higher elevation, so in subalpine openings or alpine wetlands, and we're at 3,200 feet here. So we're getting kind of high, and the geology, I think, is because there's some toxic minerals in here. We tend to get some alpine plants at slightly lower elevations. Here is Senecio triangularis. Now, even though this isn't flowering, it has some really distinct features, mainly the leaf. So, as you would expect from a species epithet, triangularis, it has a very triangular leaf with a short petiole. And it's in the aster family, the Asteraceae. So it grows in these clumps, and sometimes it's in wetlands. It's also found in wet alpine meadows. Like a lot of other Senecios, this has yellow flowers, and since it's in the aster family, it has a composite head, so it has these yellow ray florets that stick out around the outside, and then disc florets on the inside that are also yellow. Here's one that's just starting to bloom. We can see the ray florets are poking out. They're open, but the disc florets haven't opened yet. Lots of flower heads, all concentrated at the tip of this Senecio triangularis. The edge of this fen is starting to get a little bit swampy in that we're starting to get some shrubs and some trees, and we can see skunk cabbage, a common swamp plant, is growing here. And one that we covered in the swamp unit that we didn't see is right here, and I'm really excited to see it. This is the Viburnum eduli. So it has small clusters of flowers. It lacks the filaries like the Viburnum opulus, and the flowering shoots just have 2 leaves as opposed to Viburnum opulus, which would have 4 leaves, basically 1 pair lower down and 1 pair higher up with the flowers coming out of the top. But all of these flowering shoots just have one pair. Let's see, there's a couple other great kind of higher elevation swamp plants that I'm going to throw in this unit, including yellow cedar, and that's Alaskan yellow cedar, and mountain hemlock. So let's go take a look at the yellow cedar. This is Calotropis nookatensis, or Alaskan yellow cedar, and compared to red cedar, it has more of a drooping nature, so the branch tips generally point down, whereas western red cedar, the branch tips usually arch upwards. And then if you get a look at the seeds, they're very different, or the cones rather. The cones are spherical, but as they age, they turn from green to this brown color and break up into segments. So the cones on the western red cedar, they tend to be a little more like bell-shaped, where they are rounded on the top and then come down to like an abrupt flat end. Alaskan cedar cones are spherical, and they have these pointy spikes all around the outside. The bark is also really different. So behind me is yellow cedar, and we can see that the bark is a white color and it looks shaggy. So the bark kind of peels out a little bit and sticks out. Another tree that shows up in alpine wetlands is Tsuga mertensiana, or mountain hemlock. And I think it looks a little bit like western hemlock, no surprise, same genus, Tsuga, but it looks like somebody took and plugged it into a light socket. All the needles just kind of go, wah, every single direction they kind of splay out. So it's been electrocuted. If you find a cone, the Tsuga mertensiana cones are about 1 inch long, whereas Tsuga heterophylla cones are very small, usually about a 1/2 inch long. And the bark is more coarsely fissured than western hemlock. In my mind, it looks a little bit like Douglas fir bark almost. Usually it grows above about 4,000 or 3,800 feet. But again, because of the Twin Sisters geology here, we're finding it in a little bit lower elevation. Sometimes in alpine wetlands or subalpine wetlands, you get these little clumpy, kind of hummock-like island structures. And so behind me we could see 3 different tree islands, you could call them. And the topography is just a little bit higher there, it's a little bit drier, and so that is where we see the Alaskan yellow cedar and the mountain hemlock, as well as a bunch of shrubs in the understory. This is Sitka valerian, or Valeriana sitchensis, and this plant has these opposite leaves that are pinnately compound with just, looks like 5 leaflets, and then terminal inflorescence of white flowers. And these flowers have what's called a tubular corolla, so they're a little bit trumpet-like. The white structure is the corolla, and the base is tubular, and then it flares out into 5 lobes. So this is a plant that is sometimes used medicinally. Valerian comes from Valeriana. I don't think it comes from Valeriana sitchensis though, but perhaps it has similar properties to, perhaps this one has similar properties to the medicinal valerian.
Well, here's kind of a fun little find. It's something you don't see very often. This is actually a rare species of sedge in Washington State. It's very small and it'd be very easy to miss. In fact, people probably do miss it. Maybe that leads to some of its rarity, not really sure. This particular sedge is known as Carex passiflora. And what's interesting about it is that it's one of the few species that occurs in our local flora that has solitary spikes. So there's not a whole lot going on in it. Not only does it have solitary spikes, but it has very few fruits. And you'd have to look very closely, but if you look and see at the tip, there should also be a little male spike at the tip. So we say it's got a solitary spike, or solitary spikes, so it's actually got both male and female spikes on it if you look very closely, but passiflora, very few flowers on it, and unique in Washington State. Typically you find it in peaty areas. This particular one is growing on kind of a hummock made up of sphagnum moss, along with kalmia and a few other species. Another distinguishing characteristic of this sedge is not only are there very few of the perigenium, but they're also very long and skinny.
Here we have Spirea densiflora. It's just starting to flower. It's got pink flowers, and it grows in wetlands. So those 2 traits are similar to the Spirea douglasii that we saw at Tennant Lake. But the Spirea densiflora likes growing in the alpine and subalpine wetlands, and instead of having a pyramidal raceme of flowers, the flowers are in this dome to flat-topped inflorescence. Usually is a smaller shrub than the spirea, the glaucia as well. This is Phyllodaceae impetriformis, or pink mountain heather, and it is in the Ericaceae, or the heath family, and a lot of the members of the heath family have these bell-shaped flowers, or urn-shaped flowers. And you know, the heath family includes things like rhododendrons and huckleberries and blueberries, and a lot of plants, a lot of shrubs that are pretty tolerant of wet environments and extreme environments. So they grow in mountain meadows like this one, sometimes wet meadows in the mountains, and a number of them grow in wet environments, like when our bog unit, our lab is going to be on the Ericaceae. This is the only Ericaceae or heath family member that we're going to cover in this unit, but it sure is pretty, and people actually plant some cultivated varieties of heathers in landscaping because of their beautiful flowers. It has these evergreen leaves that are pretty crowded on the stem. They're about an inch long each. Here we have Symphyotrichum foliaceum, or leafy bract aster. And one of the good features for this is that the bracts, remember the leaf-like things that are underneath the inflorescence, are actually very leafy on this one. So sometimes these are called involucral bracts on a composite, a member of the Asteraceae. And these involucral bracts start to look an awful lot like the leaves because they get so big. This will later have a composite flower with violet ray florets. Some other features, we have this stem with sessile leaves, and the whole plant is glabrous. So that's the leafy bract aster, or Symphyotrichum foliaceum. We see members of the Apiaceae, or carrot family, scattered throughout different wetland types, and the only one, as far as I know, growing in the fen here is this. This is Angelica arguta, or sharp-toothed angelica. It tends to be kind of a mountain species, so I'm not surprised that it's here. And it will have later, you know, it'll grow to be about this tall, or maybe up to 3 or 4 feet tall, and has that white cluster of flowers in an umbel, like all the umbelliferae, or sorry, the Apiaceae. Used to be called the umbelliferae because of that umbel-like flower that all of them have. This is Luzula parviflora. It's actually in the Juncaceae, but it has these grass-like leaf blades. And the Luzula parviflora tends to have more diffuse-looking flower heads, and each of the branches kind of ends in one capsule. So they're not all clustered together like we've seen in some of the Juncus species. All right, we found a little Veronica here. Veronicas always have 4 petals, and one of the petals is usually a lot smaller than the rest. And this Veronica has a really hairy stem, which is a good feature. This is Veronica wormscoldii, and it is found more in mountain environments. This is a member of the Cyperaceae, or sedge family, that is not in the genus Carex or Scirpus or Shednoris or any of the other genera we've talked about. This is in the genus Trichophorum, and this is Trichophorum cespitosum, and you could really see how tightly packed or clumped this plant is, so very cespitose. Now, some minute features of the Trichophorum cespitosum, and actually all the trichophorums, is that the spikelet is terminal, and it is subtended by one large scale-like bract. And we know that it is just a bract because it doesn't have a flower inside of it. It's just empty on the top side. And the scales that are fertile on the terminus, They're arranged spirally. Trichophorum cespitosum. This is Struthiopterus spicant. It used to be Blechnum spicant. I'm still adjusting to the new name. And this isn't necessarily a wetland plant, but you can find it in wetlands now and then. And I think of it more as like a higher rainfall plant. Tend to see it in areas that get over 40 or 50 inches of rain a year. This fern has these photosynthetic leaves and then these reproductive leaves, I guess you could call them, that are that stick straight up, whereas the photosynthetic leaves usually are more peripheral. And it looks superficially like sword fern, I'd say, except that when you look at the leaf, the pinnae where they attach what would be leaflets if it was a flowering plant, they attach along the whole length to the central stem, as opposed to sword fern where they just attach at one single point. So this tends to grow, at mid elevations and up to maybe the mid elevations. It's a mid elevation fern, I'd say. Okay, that's Struthiopterus spicant. If Struthiopterus spicant is too much of a mouthful, you could just call it deer fern, but not on the quiz.
All right, I'm back again. This time we're going to look at something that I don't think you looked at all today, actually. You've seen a lot of things that are very similar looking. We call things that look like grasses graminoids quite often, and you've looked at a lot of sedges today and maybe a few other things, probably some juncus. But this is actually, I think, the first true grass that we've looked at today. It's kind of an interesting plant. It's something I don't see a whole lot. It's Hierocloa or Hieroclo odorata, and it's got kind of a nice vanilla scent if you let it dry out a little bit. So how do you tell the difference between a grass and a sedge and a juncus? Well, if you look at juncus, you'll see that it's actually got things that look a lot like petals. We call them tepals. When you have sepals and petals that look the same, we call them tepals. Juncus also has pods that tends to have a lot of seeds in it. Sedges and grasses are a little bit different. If you look at a sedge, you'll see that it usually has something called perigeny or perigenium, some sort of actually what they are is bracts that have adhered together that enclose the actual seed. And you see that they've also got these very reduced flowers. So you don't see anything called tepals or anything that looks like a petal or a sepal. And that's true of grasses as well. You've got these really sort of very reduced flowers. You definitely see the reproductive parts. And if you could see up close, you would see that this has actually got stigmas sticking out, and there's probably some anthers in there someplace. I can't really see without my hand lens. There's a very specific terminology that goes with the various parts of plant flowers. And I don't want to say it's entirely unique, but it's somewhat unique, and it's worth learning if you want to really delve more into grasses. And usually when you're looking at a grass floret, you start at the, what shall we say, the base of the stem. There's usually a couple of bract-like things. They have a special name. They're called glooms. And so typically there's two glooms, gloom number 1 and gloom number 2. And they basically enclose perhaps other bract-like things known as lemma, and possibly another bract-like thing called a palea. I know that's a lot of stuff happening before you ever get to the male and female flower parts. So anyway, that's kind of a grass floret or flower in a nutshell.
All right, I found a vaccinium that I'm really excited about because it's actually a plant that I track pretty carefully. This is called Vaccinium cespitosum. We've heard that word cespitosum a lot, or we thought about it a lot in terms of grasses and rushes being clumped. Well, this vaccinium is also pretty clumped, and so that's why they call it Vaccinium cespitosum. Now, there are really just two vacciniums that show up in wetlands. Vaccinium, at least in western Washington. As you go further north, there are more. But That's not true at all, actually. So we have some cranberries that are definitely water-loving vacciniums, like Vaccinium oxycoccus. But the vacciniums include cranberries, blueberries, and huckleberries, and only 2 of the blueberries show up in wet areas. Vaccinium uliginosum, which is bog blueberry, and this Vaccinium cespitosum. And the Vaccinium cespitosum grows more in seasonally wet areas rather than bogs, and more so in the mountains, and especially in the Twin Sisters area, which we are now. It somehow tolerates the geology here that's filled with some toxic minerals that keep some other plants out. So some features of the Vaccinium cespitosum that are easy ways to identify it quickly are these flowers that are very small and are much longer than they are wide. All right. And another good feature is the leaf margins are finely serrated. So Vaccinium cespitosum has a blueberry that is about maybe half the size of a store-bought blueberry, but they're really delicious, and it's a good one to find. I'll have to come back here in a couple months so I can snack on it. Okay, here is our last sedge of the day. This is Carex lenticularis. The common name is lakeshore sedge. It does often grow in lake shores. It especially likes areas where there's quite a bit of water fluctuation. The seeds germinate better when the ground dries up, but the plant grows well in saturated soil. So, now, one of the gestalt features that I like about this plant is just how neat and tidy it is. I sometimes call it the tuxedo sedge to people just because it just is so polished looking. The black scales in contrast with the green perigenium and the very kind of upright spikes. You know, everything is pressed together really tightly. It doesn't have a shaggy appearance like this Carex luteolina, which I showed you, is sort of the antithesis. This is kind of the bum sedge. This is the tuxedo sedge. I'm just making that up right now, but if it helps you remember it, you can go with it. Let's see, the spikelets have peduncles, but they don't dangle at all. They're upright on the peduncles, especially the lower spikelets have longer peduncles, whereas the top spikes are sessile. And then we have the terminal spike is all male. So very neat and tidy, smooth stem, smooth leaves. That's the Carex lenticularis. Another way that I remember the name of this one is that the perigenia are really, really small and make me think of lentils. But you could easily go astray with that because most perigenia look a little bit like lentils. Oh, anyway, these perigenia, they are two-sided. Many of the sedges we've seen have had three-sided achenes, but the achenes on this species are just two-sided. All right, that's the last sedge for the day. We have covered a lot of ground with sedges. I know sedges are a challenging group, and you might have to spend a little more time studying for this week's quiz on account of the difficulty of sedges. So I've given you fewer than 30 species, whereas normally I've been trying to target 30 species. I think we've covered something like 25 or 27 species in this unit. That's all for this time. Next unit will be on bogs. Similar looking habitat, but dominated by sphagnum instead of so much sedgy peat.